Hey students, so we are on the angle proofs notes, this page of notes, and we need to go ahead and get this word highlighted in your vocab folder so that we can get it out of the way. The rest of this is coming later. So let's go ahead and go to proof. So obviously you've seen proofs already. So let's just go over the parts again. We have the given. The given is always the first step, and you use the reason given. The last thing is the prove. That's the last step, but this reason is never prove. Okay, we always have one of our reasons, which is a definition, a postulate, a theorem, a property, an algebra property, things like that. So the actual definition is it is an argument that uses known facts, or definitions, postulates, theorems, and properties, and logic. That means that a proof uses deductive reasoning to put the steps together in order to prove that something's true. Once you have proven something in geometry, you can use it to prove something else. Okay, so here's our notes, the front page. We're just going to be putting a dot and highlighting and writing a couple of things to point out things that are going to happen in our proofs. Okay, first of all, properties of equality, properties of congruence. You should not have any questions about those. They have not changed, and they can still be used. Okay, so angle proofs, in my mind, tend to be a little bit easier because there's a lot of definitions. Before, in the segment proofs, we just had definition of segment bisector. Well, now we're going to have other definitions, but in addition, we're going to have other theorems that might be a little confusing to you. Okay, first of all, definition of congruence we've had already. And remember, this little arrow right here means that I could start with equals and end with congruent, or I could start with congruent and end with equals. It goes back and forth. Doesn't matter which one you start with. That actually, a word that we have when we did the conditional, converse, inverse, and contrapositive, that also fits in there. It's called a biconditional. Bi meaning it can go forwards or backwards. Some of our theorems, postulates, definitions are biconditional. Some of them are not. And I'll show you down here a few that are not. Okay, so remember that that's how I'm letting you abbreviate definition of congruence. Okay, so now we have angle bisector. It is a vocab word. Remember, whenever we have a vocab word, that we're going to follow with a definition of that vocab word. So we're going to abbreviate definition of angle bisector. And an angle bisector creates two congruent angles. Two congruent angles are created by an angle bisector. So if you have usually this shows up in the given. So you have something bisects angle ABC, and then the next step you'll say, oh, angle 1 equals angle 2. Why do they equal each other? Definition of angle bisector. It's really easy to get those once you figure out what the definition is saying. Okay, definition of complementary angles and definition of supplementary angles. So we will go, and as I'm doing proofs, if I leave out the of, it's okay. So definition, complementary angles, and if you don't remember what these are, write out the words so you can remember them. Definition of SUPPL angles for that one. So I want you to notice again, it's biconditional. Complementary angles make two angles that add to 90. Two angles that add to 90 are called complementary, so it can go backwards and forwards. And then supplementary, same thing, two angles that add to 180, or if I have two angles that add to 180, they're called supplementary. Okay. All right, definition of perpendicular and definition of right angle tend to go together. So I'm going to group these like that just to show that they do go together. First of all, go back up here. I like circling vocab words, vocab word, vocab word, vocab word. Okay, all of those are vocab words. That's why they're in the definition section of our notes. This is the symbol for perpendicular, and a lot of times that will be in the given as well. And so when you see that symbol, you need to know, oh, that symbol is a vocab word. What do perpendicular lines make? Two angles that form right angles, okay? And then what is a right angle? It's an angle that equals 90 degrees. So let me give you an example. Wait, let me write this down. So here we'll say definition of perpendicular. We'll use the symbol. And here, definition of right, not angles, just right angle. Get rid of that. Okay, so let me give you an example. Segment AB is perpendicular to segment CD. Okay, and let's say there's angle 1 and angle 2. So then it would say angle 1 and angle 2 are right angles by definition of perpendicular. And then it would say angle 1 and angle 2 equal 90. Well, that would be definition of a right angle. What is a right angle? An angle that equals 90. So you're going to see that you can have this one by itself, but if you have the perpendicular, you're most likely going to have this one following it. Okay, we have the angle addition postulate, and you can put AAP. But do not, if I ask you what the reason is, do not say AAP. You say with your mouth angle addition postulate. Okay, I can allow you to write AAP, but you have to say what it is. So what this is if I put a 1 and a 2 in here, angle 1 plus angle 2 equals angle ABC. And we can put the measures there. It's the measures that are equal. So part plus part equals whole. That's the angle addition postulate, just like we had segment addition postulate. If I told you BD was an angle bisector, and angle 1 would equal angle 2 by definition of angle bisector. See, these are not hard. You're going to be able to see the reasons very easily. These get a little confusing down here. Okay, vertical angle theorem, VAT. Vertical angle theorem, you will see something like this, and it'll say angle 1 equals angle 2. Your reason is the vertical angle theorem, and you have to look at the picture to know that. So I'm going to draw my little eyeballs that I like doing. For the angle addition postulate, you have to look at the picture, and for the vertical angle theorem, you have to look at the picture. Okay, that's how you know that it is angle addition postulate and vertical angle theorem. All right, complement and supplement theorems. So the way I want you to know that these are different from these is there's only one vocab word here, and there's only one vocab word here in each one. Down here, there's a bunch of vocab words. If two angles form a right angle, then they are complementary. Well, there's two vocab words in here, so that's the way you need to know, oh, they're complementing each other. A right angle makes complementary angles, okay? And notice it's only going one way. A right angle, if there's two angles that are forming a right angle, then they have to be complementary, okay? Because it doesn't say anything about 90 degrees, that's why we can't say definition of complementary angles. Okay, so this one we will say complement theorem and supplement or supplementary theorem. Same thing. If you have a linear pair, then they are supplementary. That's because two angles that are a linear pair are going to be supplementary. If I find a different way to write this and I start writing it a different way, that's fine. I will tell you. But for now, these two are going to probably be the hardest ones for you. All right. These two are, again, talking about something that is congruent. Okay, so that word has shown back up. So it says, if A is complementary to B and C is complementary to B, then A is congruent to C. Let me give you an example. If angle A is 40 degrees and angle B is 50 because they're complementary, angle C is complementary to angle B. Well, angle B was 50. What does angle C have to equal? it has to equal 40. Okay, so this is showing you that these two angles that are 40 are congruent to each other. All right, that's the congruent complements theorem. Congruent complement theorem. Complementary theorem, you can interchange those words. This one is going to be congruent supplementary theorem or supplement theorem, either way. And just to show you this one, if A is supplementary to B, let's use 180 because those are easy. And C is supplementary to B. Well, B was 80. What does C have to be? 100 degrees. And you can see that A and C are equal to each other. So this, again, ends with something being congruent. That's how you know these are different than these. I think these are the ones that are the hardest to remember. Okay. All right, let's turn over and do some practice. All right, if A is a right angle, then the measure of A equals 90. So I want you to see that this is a vocab word. If angle A is a right angle, then why does it equal 90? Because of definition of a right angle. What is the definition of a right angle? An angle that equals 90 degrees. Definition of right angle. Okay, angle X is supplementary to angle Y, and angle X is also supplementary to angle Z. Those two angles are congruent. This is the congruent supplementary theorem. Congruent supplementary theorem. Now, if you don't want to put the name of it and you want to put, like in your own words maybe, like if two angles are supplementary to the same angle, then those two angles are congruent, you could say the words. In fact, let's just write that out. If two angles are supplementary to same angle, then they are congruent. You could write it out like that. Two angles are supplementary to the same angle, then they're congruent. That's perfectly fine because that's what this word means. So memorize that. All right, number 3, I have this picture. What are these called? Vertical angles. Vertical angles are congruent to each other. So this is the vertical angle theorem. Do not say VAT, say vertical angle theorem. Okay, number 4. Measure of angle P plus measure of angle Q equal 90, then measure of angle P the angle P and angle Q are complementary. So remember, if there's only one vocab word, it's going to be definition of that vocab word. Why do these angles add to 90? Because they're complementary. What's the definition of complementary? Two angles that add to 90, and it can go forwards or backwards in any order with that definition. So remember, we're circling our vocab words to help us get these definitions. All right. All right, angle M and angle N form a right angle, then angle M and N are complementary. Do you see we have two vocab words? That's the one that I was talking about. I have another page. I'm going to lay it up here so we can see this together. Okay, that's the one I was talking about right here, where we have right angle and complementary in there. Right angle going to complementary. Right angle going to complementary. So that is the complement theorem. The complement theorem. I really don't have an abbreviation for that unless you abbreviate theorem. The complement theorem is going from right angle to complementary. Two vocab words, so it's not a definition of a vocab word. All right, number 6. Look at the picture. It tells us there's a vocab word. Y'all probably need to write vocab so you know. That is a vocab word. So if L is perpendicular to M, what do perpendicular lines form? Right angles. It says angle 1 is a right angle. So this is definition of perpendicular. See, these are not hard. Once you know your vocab, these are a little bit easier because there's a bunch of definitions. This is usually in the given. Okay, the perpendicular usually shows up in the given. The angle bisector usually shows up in the given. Doesn't have to, but it usually is. Okay, number 7. If W and X are supplementary, angle W, angle X are supplementary, then they equal 180. There's only one vocab word in there. So this is going to be definition of supplementary. Okay, vocab words are very, very, very important in this section. All right, L is complementary to M, and N is complementary to M. So we've got two angles that are complementary to the same angle. Those two angles are congruent. That is just like number 2 up here. And so it's going to be the congruent complement theorem. And if you wanted to write it out in words, you could say, if two angles are complementary to same angle, then they are congruent. Okay, so if you can't remember this one, you can write it out in words. Okay, number 9, we've got 2 vocab words dealing with supplementary. So that's going to be the supplement theorem. Going from a linear pair to supplementary, that is the supplement theorem. All right, number 10, if angle N and angle P are complementary, then they add to 90 degrees. I've got one vocab word, definition of complementary. If you look at number 4 above, number 4 and number 10, they're backwards, but it doesn't matter. Definition of complementary was biconditional. It goes forwards or backwards. Okay, number 11, all we have is a picture, and we have this statement here. And if I look at this statement, JKM plus angle MKL equals angle JKL. I have to look at the picture to know this is true. Okay, and that is the angle addition postulate. Do not say AAP, you say angle addition postulate. And then number 12, these are exactly the same, except for it's going from equal to congruent. That is definition of congruence. Okay, so now I'm going to ask you questions off of this page to get you some question points on these notes. Okay. All right, so this is telling me we are using the definition of congruence. What would you write over here? So I'll do the first one. All right. If angle D is congruent to angle E, then angle D equals angle E. And I'm okay if you put measure or if you leave that off. I'm not going to be too picky about that. But you're finishing the statement, okay, by using whatever they tell you to use. All right, so that's what you would put. All right, look at number 2. By the way, before you answer, flip over to the previous page and see if you can find something. All right, number 2, we are using the definition of complementary angles. So if angle 1 plus angle 2 equals 90, then what would be the next step? This is like your left side of the proof. What would be on the right side of the proof? Okay, so go ahead and write down your answer, and then I will ask you a question about it. All right, well, you should have said angle 1 and angle 2 are complementary, and you would have seen that definition of complementary angles. If angle 1 and angle 2 add to 90, they're complementary, or if they're complementary, they add to 90. That is the definition of complementary angles. And then over here, they add to 90, so they're complementary, or if they're complementary, they add to 90, okay? Number 3, definition of supplementary angles, okay? So if angle P and angle Q are supplementary, then what does that tell you using the definition of supplementary angles? Go ahead and write your answer. All right, well, hopefully you put angle P plus angle Q equals 180. Also, measures, again, for these questions, if I didn't put it in there, that's fine. Okay, number 4. Definition of a right angle. So if the measure of angle JKL equals 90, then what would you put? Go ahead and find what you would put. All right, so we got JKL as a right angle. By definition of right angle, if the angle equals 90, then it's a right angle. Okay. Number 5. So we have angle 3 and angle 4 are vertical angles. Usually there's a picture to accompany this. So 3 and 4 are vertical angles. Then what are you going to put? What are you going to put here? Go ahead and write that down. All right, so if you have 2 vertical angles, then they are congruent. You can have equals or you can have congruent, just depending on what the proof wants you to write. Not picky about that. Vertical angles make 2 congruent angles. You can say their measures are congruent, or you can just say they're equal. Okay, the measures are equal or the angles are congruent. Okay, remember, if you have congruent, well, you remember, if you have something extra, you have something extra. Again, not picky about it. Okay, let's skip to number 8. I'll go ahead and give you the answers to these two. I'm not going to have you do them. We would say angle S and angle T are complementary. This is the one, the complement theorem, where you have 2 vocab words. And then the supplement theorem, if you have X and Y forming a linear pair, then angle X and angle Y are supplementary. Again, 2 vocab words. Okay, the congruent complements theorem. If angle, you can look back and get the answer for this. If angle 1 is congruent to angle 2 and angle 2 is congruent to angle 4, then which 2 angles are going to be congruent? So out of 1, 2, and 4, which 2 are going to be congruent? Easy answer. Go for it. All right, so you should have put angle 1 is congruent to angle 4. By the way, I can't put congruent in my typing on the page, so I usually write out the word if I can fit it in there. Okay, and then the same thing for number 9. I'm not going to ask you about that, but it says if angle J is supplementary to angle K and angle J is supplementary to angle L, then angle K equals angle L. I hope this is looking a little bit easier to you. Okay, let's do a couple of proofs. Now, these notes are a little bit long, but like I said, I'm okay with them being long because the more we do, the better you get at it. All right, so in this picture, we have angle 1 and angle 2 form a linear pair. Angle 1 and 3 are supplementary. Okay, so I want you to see I have 2 givens. You need to find the givens in here and write given. Angle 1 and 2 form a linear pair. That is given. And sometimes I'll do this just to show that I found it. Angle 1 and 3 are supplementary right here. See how they put that given further down? That's because they're going to use it down here. You don't have to do that if you're writing a proof. You can put them both in the same step. It's just how the person who writes the proof decides to do it. Okay, so let's go through and logically put these pieces together. All right, if angle 1 and angle 2 form a linear pair, why are they supplementary? All right, what reason from everything that's on the front page, you can have the front page of your notes up. What reason? Now, I want you to notice here, this is where we have the 2 vocab words. So the reason that angle 1 and 2 form a linear pair and then angle 1 and 2 are supplementary is the supplement theorem. Okay, I just stopped and I looked at what Ms. Kotler puts down for the supplement theorem. So if you're going from linear pair to supplementary, she puts linear pair postulate. So I would actually take either one of those. It might be easier to remember linear pair postulate, and we put LPP if you want, linear pair postulate. So because we have the vocab word, but it's not definition of linear pair, it's the linear pair postulate that says a linear pair is made up of angles that are supplementary. So, you know, it's going to be one way or the other. And you can pick one. It doesn't matter. Okay, so I will remind you as we go through here that you can put linear pair postulate. Okay, let's look here. So angle 1 and 2 are supplementary. Why do they add to 180? So we are going from supplementary to 180. When you look at the front of your notes, you see from supplementary to 180, supplementary to 180, that's going to be definition of supplementary angles. Definition of supplementary angles. Okay, and then we have, so this, the reason they put this down here is because everything up here dealt with angle 1 and 2. Angle 1 and 2 form a linear pair, so they're supplementary. Angle 1 and 2 are supplementary, so they add to 180. See how that all flows? Okay, the reason we're getting these equal to 180 is because that's where you do your substitutions, and that's where you do your additions and your subtractions. So we've got to get away from the vocab words and get into the math of it. All right, so now we're going to look at angle 1 and 3. Angle 1 and 3 are supplementary. Well, why do they add to 180? Vocab word. Why do they add to 180? Definition of supplementary. Definition of supplementary angles. Okay, now look at what's happening. We are taking step 3 and step 5 and we're putting them together. So I want you to see step 3 is equal to this. Step 5 is equal to this. So if these are 180 and these are 180, 180 equals 180. Okay, 180 equals 180. So that's going to be, you could either put substitution or transitive. So remember, I take either answer, but I want to show you why I'm putting transitive. Property of equality, because there's equals. Engine to middle car to caboose, engine to caboose. We're taking out the middle, and putting the first with the last. Even though this is out of order, it's okay. And so when we take out something from the middle of each one of these, it's transitive. We typically use substitution when we take out one little piece, but if we're setting two things equal to the same thing, that's going to be transitive property. Okay, so then to go from here to here, look at what happened. Angle 1 has disappeared. How do we get rid of an angle? We subtract it. So we are subtracting angle 1, subtraction. Okay, and then we're going from equal to congruent. Definition of congruence. There you go. Okay, let's do another one. I love this. It has bisect. Okay, so it says ray KM bisects angle JKL. Let's find that given. That's right here. And now we're going to take what a bisector means. So what does a bisector do? It makes two congruent angles. Okay, so the next step is the measure of angle JKM. JKM is equal to the measure of angle MKL. These two angles are equal. Why are they equal? Because of this step. So we've got our bisect. You've got to tell me, you cannot say definition of bisect. You have to tell me what kind of bisector. We have angle bisector, segment bisector, perpendicular bisector. You have to tell me which one. So this is definition of angle bisector. That should make sense to you. Vocab word, definition of the vocab word. And you have to put the angle bisector because that's the picture. Okay. All right, so now looky here. I've got something plus something equals something. Whenever that happens, put your eyeballs on the picture to see if it's angle addition postulate. Angle JKM plus angle MKL equals angle JKL. That is angle addition postulate. Okay, now I want you to look at step 4 and see what is happening. Look at what's different. All right, this is the same. This is the same. This has been substituted with this. So they took this out and replaced it with this because they were equal to each other. So we took this out and replaced it with that. That is substitution. Property of equality. Okay. Typically, change that to look like a P. There we go. Typically, substitution will follow segment addition postulate and angle addition postulate. Not always, but it happens a lot. It happens enough that we can recognize that it's happening a lot. Okay. All right. So what happens? How do we get a 2 in front of here? These are exactly the same. It is not addition. Addition has to happen on the left and the right. So this is not addition, but this is simplify or substitution. You can think of this as substituting both of these. I'm going to let you start writing simplify. So it's happening a lot. We're going to go ahead. I'm going to let you put simplify. Okay. If you go get help from Ms. Kotler or one of her students, they won't have this because they put substitution. Simplify is an appropriate steps that we can have. And then how do I get the 1/2? We're dividing by 2, dividing by 2. That is division, property of equality. See how that flowed? That was not a hard proof. I would expect you to be able to write this proof eventually. Okay, so we've got our making two congruent angles. Anytime you have a picture like this, you're going to have the angle addition postulate, a typical substitution, and then it just flowed where it was simplifying and division. That's not hard. Okay, all right. Number 12. Let's find all of our givens. We've got perpendicular. I want you to circle that because that is a vocab word. Okay, and I've got vocab word here. All right, so pay attention. We're going to have some definitions in here. We've got 2 givens. Let's go ahead and put them down. The other one looks like it's right here. Okay, so BD is perpendicular to BC. BD is perpendicular to BC. What do perpendicular lines form? Right angles. Okay, so why is this a right angle? Why is angle DBC a right angle? Definition of perpendicular. So I want you to circle this and draw an arrow because that is a typical vocab word setup. Okay, so why is the measure of angle DBC 90 degrees? Because it was a right angle. Vocab word. All right. Vocab word. What do you think is going to go right here? I'm going to let that be one of the questions that I ask you. What is the answer for step number 3? Definition of right angle. You should have got that. You should have got that right. I'm sorry. Okay. Now look at step 4. So now can you see that step 4 is a total change of pace because it's not just vocab numbers. We go to this statement where you need to recognize that this might be angle addition postulate. You do enough of these, you start to recognize it. So my eyeballs go where? To the picture to see if it's angle addition postulate. The measure of angle DBE plus the measure of angle EBC equals the measure of angle DBC. That is angle addition postulate. And my eyeballs went up here to look. Okay, what did I say up here typically follows AAP, angle addition postulate? Some kind of substitution. So let's see if that's going to happen. This stayed the same. This stayed the same. They took out angle DBC and they equaled it to 90. How was I able to do that? Because it told me right here that they are equal. So this is a substitution, taking out angle DBC and putting in angle 90. Okay. And then we have our given thrown in here again because now it's going to make sense to say that angle ABD is equal to angle DBE. So these two angles are equal. Okay. So let's see what's going on from here to here. Oh, they're congruent, not equal. Sorry, they're congruent. Angle ADB is congruent to angle DBE. Now I'm saying that they're equal. Definition of congruence. Why do we do that? Because when we put numbers into the problem, we have to have equals. We can't put numbers into the problem with congruent. Okay, so now we've got these two angles are equal. So now let's see what's happening here. Angle ABD plus angle EBC. Did we have that up here anywhere? If you notice right here, look, this is exactly the same, exactly the same. This has now changed to this. Why were we allowed to do that? Because of this step right here. So what I've done is I've taken out this and I've put in this. I'm going to connect these right here. So you know these are the two steps that we're looking at to go from here to here. So that is a substitution. And then if two angles add to 90, they have to be complementary. Vocab word, I have nowhere else to go except straight across. Definition of complementary. Not too bad. Not bad at all. We are going to do this one in class. So you are done with your notes. And after we do this one in class, you'll be doing worksheet number 16. And hopefully you'll feel a little better about filling in. I think on your homework, you're going to have to fill in the left and the right with spaces like this to kind of help you get used to writing the proofs over here. Okay, thank you, students.